Okay, so today we're going to be learning about improper integrals with infinite limits, which is just chapter 8.4.
So I remember when I was first doing this chapter that, to be honest, the thing that I got confused on the most wasn't actually the concepts we were learning, but integrating, because I'd gotten so used to using my calculator that I'd forgotten how to do it. So we thought we'd just do a quick review of how you integrate things. So there's basically three different methods. There's biparts, which is the uv minus v du, or you can do tabular integration for that. There's partial fractions, which is a over x minus c plus b over x plus d. We'll go over that one in a bit. And then there's u substitution, which is probably the most common one that you'll use. So I probably should have listed it first, but whatever.
Okay, so for this problem we're going to show you how to use u substitution. So you have the problem integral from 0 to infinity of 2x over x squared plus 1 dx. So first, this is improper. So to make it proper, we have to take the limit of it. So we take the limit as b approaches infinity of integral from 0 to b in that same problem. And then from here we use u substitution. So the easiest way would to have u equal x squared plus 1. And the derivative of that would just be 2x dx. So then plugging those back in, we get the limit as b approaches infinity of integral from 1 to b, 1 over u du. And then we know how to do... And then the integral changes from 1 to b because if you plug in 0 to what the u substitution was, you get u equals 0 squared plus 1, which is just 1. And then if you plug in b, it'd be b squared plus 1, which is b, so the integral changes from 1 to b. And then you take, from here we know how to do the antiderivative. So we get the ln of absolute value of u, such that from 1 to b, which equals the ln of absolute value of b minus the ln of absolute value of 1. And we know that the ln of absolute value of 1 is 0. So then we get the infinity minus 0, which is just infinity, which it diverges.
Okay, and so in this problem we are going to use partial fractions. So we have the problem from negative 1 to infinity. So the first thing we're going to do is, again, we're going to substitute b in for infinity just to represent it so it's easier to do. So we're going to have negative 1 to b as our integral. And then we're going to do partial fractions. So the way that you do that is you break up the bottom. It's when you can factor the bottom. So for example, for this one, it becomes x plus 2 and x plus 3. And then you put a over x plus 2 plus b over x plus 3. And then you're just going to set those two things equal to the numerator. Well, actually, sorry, first we cross multiplied. So that's how we got what we got there. So we got a times x plus 3 and then b times x plus 2. And then you set that equal to the numerator, which in this case is 1. So the 1 comes over here. So you can see that. Sorry, I kind of circled it, so now you can't see it. But know that that is a 1. And so then you want to make this easy to solve, so you can plug in different values for x. So in this case, the easiest way to solve it would be if you plugged in negative 2 for x for this, because that would make the b go away, and then plug in negative 3 for x. So that's where we wrote. Okay, so then, yeah, you plug that negative 2 in, and you plug in the negative 3 there. So you get b equals negative 1 and a equals 1. So then you plug those back in for your a and b values. So for example, that would be, right here would become 1, and this would become negative 1. So now you're just going to integrate that, if I can flip the page. Okay, so then you still have your limit of as b approaches infinity for negative 1 to b. You've plugged in your a and b values, and now you just have to integrate it. So 1 over x plus 2, you'll probably remember, is the natural log of x plus 2. And then you're going to go from negative 1 to b. And then you're going to have this be minus, because remember, this is a negative 1 up here. So that makes this a negative. So that becomes negative natural log of x plus 3 from negative 1 to b. You just plug in your stuff. Natural log of 1 approaches 0. Sorry, I'm trying to go fast here. I'm just trying to figure out what to tell you guys. Okay, then you have the natural log of b plus 2 minus the natural log of b plus 3, which a cool rule of natural logs that you may or may not remember is that when the two are subtracting, you can just divide the inner natural log values. So that's how we got this. So that's a natural log of b plus 2 over b plus 3 plus the natural log of 2. And then because... which that basically goes down to natural log of 1, because the two values of b are probably about the same, which equals 0. So you're just going to have 0 plus natural log of 2, which equals natural log of 2. Okay, And then this guy I'm going to go over really quick because I'm sure you can figure it out. It's not too bad. The only tricky part of this is it goes from 0 to 2, so it doesn't actually involve an infinity value anywhere in it. So the reason that this is improper, though, is because you have the denominator saying x minus 1. So if you plug in 1 there, that would make the denominator 0. You would be dividing by 0, and that makes it improper. So you're going to have to break up this integral and make it go from 0 to 1 for this guy, and then from 1 to 2 for this guy. Just for future reference, that's also how you treat problems that go from negative infinity to infinity. So you just break up your integral, like we did here, and then you just do the same stuff. So you replace the 1, which, because it's your improper value, with b, so it's the limit as b approaches 1, and then you plug in what you know, and then you just solve for it. So you'll end up having infinity minus 0 minus infinity, which gets you infinity plus infinity, which diverges. And then we're done. Woohoo! Go math now. We love you guys.